First, I have to analyze what this is. I can decide what to do before I analyze. 3 from the left, who cares? The square root of 3. But what about the denominator? What will I write for the denominator?
Zero.
Very good. So again, the square root of 3 over 0 is no hope. No hope means one of these three options. All I need to do is analyze the sign. Okay, 3 from the left, who cares? 3 from the left or 3 from the right, this is still a positive number. But remember now, for the denominator where it's 0, 3 from the left, I have to imagine to plug in 2.9 because I need the sign. And only when I find out the sign, then I will choose among these two, or between these two. I shouldn't say that. So what is the sign if you plug in 2.9? Just the sign, no calculations are required.
Negative.
Yes, so then what will I write?
Negative infinity.
That's it. And I have to say x equals 3 is a vertical asymptote. Perfect. Any questions? Okay, I'm sharing my screen. Is this okay?
How about 34?
34. I think we did it last time, but maybe not. So let's take a look at 34. Limit as x approaches 0 from the right, natural log of sine x. Maybe not. Okay, let's take a look. Very good pick. So I always start from the inner function, like evaluating, right? So as x approaches 0, 0 from the right is with angles higher than 0. Where is this going? Sine is measured on the y-axis. What is the y value of this point?
Zero.
Excellent. Of course, it's 0. 0 from the positive values, not 0 from the negative. 0 from the positive. Now, I'm asking myself, natural log of 0 from the positive side. Well, immediately I have to picture in my head natural log. Here it is. This is natural log x. Where is natural log x going as x approaches 0? Where is natural log going as x approaches 0 from the right?
Negative infinity.
Brilliant. My students are getting it. But remember, you have to remember that you have to know the graph of natural log. You have to immediately picture for any trig function, you have to picture the unit circle. And now I can go back. I think this is dry.
So then do we put x equals 0 for the vertical
Yes.
asymptote?
Thank you. X equals 0, vertical asymptote. Thank you. Absolutely. Thank you very much. Okay, good. I'm sharing my screen. Are we exhausted? Have we exhausted this or not yet? These have a little bit of concept, but not a lot of work, as you've seen. I didn't have to write 3 pages to find it. I'm not saying that they are not important. They're very important, but I'm saying they require more thinking than doing versus these ones. Here I have to factor, I have to simplify. We have other simplification ones, or can we move on to another topic?
I'm ready for another topic.
Okay, so let's go through. So this was some limits. If we have time, we'll go back to more limits. Do we want to see another example in which we are determining numbers and plugging in numbers in the calculator to determine the slope of the secant line, which is the average rate of change, and then closer and closer to the slope of the tangent line? That was the first thing we did this semester. Do we want to do that? Or that is clear and we should move on?
Just a few examples will be fine.
We want to? Yes?
Yes, please.
Perfect. So this is in 2.1. Let's quickly go there, 2.1, and choose an example. Any function you want. Just remember, I would definitely look at all written homeworks with solutions immediately because we had those. Okay. Would you like to work on 4? I don't remember if 4 was the homework problem or not. No. Do you want to work on 4?
Yes, it's fine.
Okay. So we have the point. I am on page 7. And this is 4 in 2.1. Okay, so we have a point. The point is 0.5 comma 0. And the curve is cosine pi x. Done. Okay, so of course point Q will be x comma cosine pi x. And find the slope of the secant line. Of course. So I need to put these numbers in the correct order. So the point is 0.50. So 0.5 is the key. So I have x. Watch me run out of room. I always do. And MPQ. So 0. Okay, closer. Okay, so we have 0. We have 0.4, 0.49, 0.499. Of course, I'm going to put 0.5, although it's not legitimate at this point. 0.501. Everything is in the ascending order.
Can you please stop sharing the screen?
Yes, let me copy them and then I'll show. Yes, absolutely. And we need to copy those numbers first. Okay, so I started with 0. This is the key. Has to be somewhere in the middle in this case. So 0, 0.4, 0.49, 0.499. Of course, that's what I want. And the other side, they are going higher and higher. 0.501 is next. 0.51 is next. 0.66 is next, and 1 is the last one. I will create the slope PQ. y2 minus y1 over x2 minus x1. So cosine pi x minus 0, I shouldn't even write it, but I will. X minus 0.5. That's all I need to do. Plug this in calculator. And then these numbers. That's all I need. It should take like 3 minutes. It takes longer to plug this in than to find those numbers. Okay. Be careful now. If this is not 0, you need parentheses around the top. But you definitely need parentheses here in the calculator. You definitely need parentheses here in the calculator. If this is not 0, you also need parentheses here. If it's 0, you can get away with it. Okay, I'm going to share my screen and plug it in. Where's my share button? Okay, so where's my calculator? Here it is. So in y equals, clear. Make sure again that the mode, every time you're entering a trig function, make sure that the radian mode is showing. So y equals, left parenthesis, I can skip that. I have cosine, and then pi x. Here's the sign for pi, the caret, okay, and x, and close, and divide in parentheses by x minus 0.5, x minus 0.5, and close. All I have to do now is go to second and table and plug in my numbers in that order, and that's it. 0, 0.4, 0.49. Don't do this by hand separately. It will take forever. I'm very optimistic and I want to plug in 0.5. It's good. The calculator should scream at me. Good. 0.501, 0.51, 0.6, and then 1. And now I'm copying all these numbers. So I have -2, -3.09, -3.141, -3.142, -3.142, -3.141, -3.09, and -2. And now I want to be even closer to, because they are asking me to find an estimate for 0.5. So I'm going to plug in 0.500000001. Okay? That's it. See, you can say, oh, wait a minute. When you plugged in 0.5, it gave you an error, but now you plugged in 0.5 and it gave you -3. I fooled the calculator by plugging in as close as I could to 0.5. 0.5000000, I don't even know how many zeros, 1. And I fooled the calculator. Okay? So the slope of the tangent at P, -3. And let me share my screen. I didn't mean to do that. Where is it? Okay. So using the result of part A, guess. Fine. Using this, okay. Using the slope from part B, find an equation of the tangent line to this point. Sketch the curve. There is no need. We can do that. We've done that. It's, you know, it's basically this. The secant line and the slope of the tangent and the tangent line. So y minus y1 equals the slope times x minus x1, where this is -3, and this is 0.5, and this is 0. And then we have y equals -3 and x minus 0.5. I distribute y equals -3x plus 1.5. So this problem, although it sounds or looks fantastic, it should take 3 minutes. Okay, so that's accomplished. Okay, back to our list. Do we still want a piecewise defined function, or are we okay with that? Okay. Do we want the squeeze theorem?
Yes.
Okay,
Please.
so let's look at the squeeze theorem, and that's in 2.3. 2.3. Okay, towards the end somewhere. Use the squeeze theorem to show this. This we already did both of them, one in class and one. Okay, and prove this. Of course, these are specific for squeeze theorem. Okay, 41. So we have limit as x approaches 0 from x to the 4th cosine 2 over x. I don't remember doing this. Have we done that? I don't think so. Okay, so first I have to see where this is going and what's the situation here. Okay, of course this approaches 0, but this is D and E. How do I know? Picture the graph immediately. Here it is, 2 over x or 1 over x, same thing. Here's the graph. So 0 from the left and 0 from the right, they go in opposite directions, D and E. So then our only chance is the squeeze theorem. So in step number 1, I have to do the squeeze. And I always start with cosine, because cosine is a bounded function between -1 and 1. So I have this piece, but that's not enough, because this is my function. All I have to do is multiply all 3 sides by x to the 4th. But I have to make sure that this is positive and never 0, because I cannot multiply 3 sides of an inequality by 0. This is positive, always it's positive. And it's not 0, how do I know? Because this specifically says not equal 0. So I multiply. I did the squeeze. This is my function. This is the lower bound, and this is the upper bound. So this is my g of x, and this is my h of x. The first step is fulfilled. Step number 2 is even easier, because I have to find the limit as x approaches 0 from the lower bound, and the limit, of course, the same thing, as x approaches 0 from the upper bound. Notice this one needs parentheses, this one does not. And if these two exist and they are equal, then by the squeeze theorem I'll conclude. Can anyone give us the answer here? And this is when the limit operator disappears.
They're both equal
I
to
say
0.
both 0.
Good. So then I'll write from 1 and 2, and this will never stay as I wanted it to, by the squeeze theorem. What do I conclude about the limit as x approaches 0 from x to the 4th cosine 2 over x? I showed that it's squeezed, and the limit of the top and the limit of the bottom exist. They're equal and equal to 0. What do I conclude here? From these two, and I have to write from 1 and 2, comma, by the squeeze theorem, I get what?
0.
That's it. Back to our list. That's all you have to write. It should take 2 minutes, 3 minutes at the most. That's the squeeze theorem. Okay, do we want to look at IVT again?